Welcome to this guided practice on moles and molar mass for AP. Let's go ahead and take a look at question number 1. So we have vitamin C, which is an essential vitamin that cannot be stored in the body. Humans must get vitamin C by consuming it in their diet. And what we want to know is what is the molar mass of vitamin C? And so we have this formula that is C6H8O6. And so in order to do this, we want to take 6 times the mass of carbon, the molar mass on the periodic table. So 6 times 12.01 grams for carbon. We're going to add that to the mass of hydrogen. And there's 8 of them, so 8 times 1.008 grams. And then we have to also add in the oxygen. So we have 6 of them, so 6 times 16.00 grams. Now my students know in class a lot of times I will round these to the whole number, but I'm just trying to show those decimal place values that would come from the AP chemistry periodic table. So we go ahead and put this in our calculator and we find out that we get 176.12 grams, and that's going to be grams per mole, okay, if it's a molar mass. So you might see it written either as just grams or grams per mole. All right, so now we can actually use that value. A lot of times I'm just putting that into a calculator, but I want to show out that process to show how we do that. Now the second part B here, how many molecules are in 250 milligrams of vitamin C capsules? So we want to know molecules. We are given milligrams. So one of the things we have to do is go back and use our knowledge of milligrams to grams. So we know that there are 1,000 milligrams in 1 gram, because in order to do any conversions with moles and molar mass, we have to have grams. So you can actually move the decimal originally, or you can just put it into your conversion, which I think is actually a bit easier. So here we go, 250 milligrams. There are 1,000 milligrams. Remember, we want milligrams on the bottom to cancel milligrams that we started with on the top per 1 gram. So that's our first step, and we can go ahead and double check those unit cancellations as we go, or we can just do it at the end. Our next part is going to be to use the molar mass we got from part A, and so we know that for every 1 mole there were 176.12 grams, so that will go on the bottom and 1 mole will go on the top. Now we're not done yet because we want to know molecules, and so we have to come back around and use Avogadro's number. So on the bottom, we want to cancel that 1 mole, and we know for every 1 mole there are 6.022 times 10 to the 23rd pieces. And so molecules are the individual pieces. MLQS, I know my Q is sometimes a little strange. Some of my students give me a hard time about that. All right, and so we go ahead and do the math on this. Let's just double check that we got our units canceled properly, and it looks like we're good. We're in molecules. So we're going to multiply across the top, multiply across the bottom, divide top by bottom. I always recommend when you are working in exponential notation or scientific notation that you're using the EE button if you're using a TI calculator. And if you have questions about that, we can go over that in class. So I ended up getting, with Sig Figs, so we started with 2 significant digits, 1, 2. Okay, the 0 is not significant, it's just a placeholder in that 250 milligrams. So that means my ending is going to be 2 significant digits, so 8.5 times 10 to the 20th molecules. All right, so that concludes B. We've found molecules. Now let's go ahead and we're going to actually work these a little bit, the opposite direction. So the first one for part C, the daily recommended dose of vitamin C for women is 2.56 times 10 to the 20th molecules. How many moles of vitamin C are in the daily recommended value? So let's go ahead and start with this value of 2.56 times 10 to the 20th molecules. Okay, so 2.56 times 10 to the 20th molecules. We're going to use Avogadro's number to work our way backwards. So there are 6.022 times 10 to the 23rd molecules for every 1 mole. And we were asked about moles, so that's what we're going to go into. So we'll do that calculation. This is where it's really important to either use parentheses when you're entering in the calculator or use that EE button so you don't end up with the wrong order of operation happening in your calculator. We have 3 significant digits in this original value now, so we want that in our ending. So we're going to have 4.25 times 10 to the -4th moles. You could write that also as a decimal, but we'll go ahead and write it in scientific notation. Oops, I cut off part of my number there. Let me redo that. There we go. All right, and then finally, how many milligrams would that be? So we're going to go from moles to grams and then grams to milligrams. So let's start with our 4.25 times 10 to the -4th moles. We're going to go back and use that molar mass that we started with in part A. So we know for every 1 mole, we had 176.12 grams. And then finally, we want to convert to milligrams. Again, you can move decimals if you like to, but if we're already doing this calculation, I find that I make less mistakes if I just go ahead and put it in. So 1 gram, 1,000 milligrams. Check our units if we want to. Plug that into our calculator and we should get 74.9 milligrams. All right, take a look at some of the independent practice and get a little more experience with these.